This is pre-algebra. Today we're going to be adding and subtracting both fractions and mixed numbers. Make sure you add this to your Cornell notes. Make sure you take your notes well. Let's define some terms. Fractions. Fractions are when you have a part of a whole. So over here, I've drawn a whole sort of candy bar. We're going to color in a fractional part of it today, a piece of it. And mixed numbers are when you have a whole number and a fraction. These are both examples of mixed numbers. Okay, here we go. Adding and subtracting fractions. Let's start by just adding some fractions here. I have 3/4 and I'm adding 1/4. Here's my whole thing. And I'm going to begin with 3/4 of it. The 4 means it's cut into 4 equal pieces. 1, 2, 3, 4. The 3 means that right now I have 3 of those pieces. 1, 2, 3. Fair enough. Now, I'm adding to that one more of those 1/4 pieces. Here's one more 1/4 piece. All told, that means I have 1, 2, 3, 4 of those 1/4 pieces. It's still cut into 4 pieces. Notice that my denominator doesn't change. It's cut into fourths. In the end, it's still cut into fourths. I didn't recut it. All I did was I started with 3 pieces. I added one more piece, so altogether I have 4 pieces. We can simplify this number. 4 out of 4, that means it's cut in 4 pieces and I have all 4 of them. That's the same as one whole. Anytime your fraction is the same on the top and the bottom, that's the same as 1. Okay, so adding fractions. Let's subtract a fraction now. Hey, wait a second. This fraction would be cut into 8 pieces, and this one would be cut into 12. It's going to be hard to know how many pieces I have if some pieces are 1/8 size and other pieces are 1/12 size. I need my pieces to be cut into the same size if I want to add or subtract. Here I was lucky they were already in the same size, so I could just add. Here I'm going to have to do something before I'm able to add these because the pieces are different sizes. Here's what I need to do. I need to think about cutting my pieces into the same size. To do that, I want to think, is there a way that I can count by 8s or count by 12s and end up with the same number? So 8, 16, 24, 32, 12, 12, 24, 36. Wait a second. I could split these both up into 24th pieces. So I'm still subtracting, but instead of cutting them into 8s and 12s, I'm going to cut them both into 24s. Because if I take each of my 8 pieces and I cut them up 2 or 3 different times, I get 24. If I take my 12 pieces and I cut them 2 times, I get 24. Now, let's see what we need to do to the numerators. Remember, denominators at the bottom, that's how many pieces. Numerators at the top, that's how many pieces you actually have. My 8 pieces, I had to cut each one 3 times to get 24 pieces total. That's the same as multiplying times 3 times 3. I took my 8, I multiplied by 3, I got 24. In order to keep my fractions equivalent, to make sure it's still representing the same thing, I'm going to need to also cut these 3/8 pieces into 3 pieces each, which is the same as multiplying times 3. Another way to think about that is that if I do something to my denominator, I must do the same to my numerator. 3 times 3 is 9. All right, let's try this side. I had a 12th size piece. I cut each one in half, so each one is now 2 more than it used to be. So I have 24 pieces total. That's like multiplying times 2. If I'm going to multiply times 2, this is going to multiply times 2 also. 2 times 2 is 4. Now I can subtract. I have the same size pieces. In my answer, I'm still going to have 24 size pieces. I have 9 of them. I'm taking away 4 of them. In the end, I'm going to have 5 24th size pieces. Let's try the same system with some mixed numbers. When working with mixed numbers, try to add and subtract just the fractions first, and then the whole numbers. Sometimes you may have to regroup. We won't do regrouping today. But please don't start with the whole numbers. Please always start with the fractions. Here we go. I'm going to start by looking at my fractions. I have 1/4 and I have 1/2. I can't add them just yet because they have different denominators. However, if I cut this half, each of these into 2 pieces, I could make it be in fourths. Then I could add them. So let's multiply this times 2. So that each of these pieces is cut in half, and I end up with 4 pieces total. Times 2. I'm going to do that to the 2 to get a 4. I'll need to do that to my numerator as well. 1 times 2 is 2. My 1/4 is already in 4th size pieces. I'm just going to add my fractions, then I'm going to go back and look at my whole numbers. 1/4 plus 2/4 is 3/4. Now let's look at my whole numbers. I have 2 and I have 3. 2 plus 3 is 5. My answer is already in simplest form. I don't need to do anything else. Let's try subtracting. I have 7 2/3 minus 4 2/6. Well, if I took these pieces and multiplied each one by 2, I would have 6. Let's do that so I can subtract. 3 times 2 is 6. 2 times 2 is 4. Minus 2/6. Notice I'm just doing the fractions right now. I'll come back and get the whole numbers in a minute. 4/6 minus 2/6 is 2/6. And I have 7 and 4 now. 7 minus 4 is 3. Let's rewrite this in simplest form. 2/6. Each 2 and 6 will divide by 2. 2 divided by 2 would be 1 divided by 2. And 6 divided by 2 would be 3. So the best answer to this problem would be 3 1/3. 2 things you should have taken away today. 1, you must have a common denominator to add and subtract. 2, when working with mixed numbers, do the fractions first and then the whole